Let's solve this problem LeetCode74. So search a 2D array. So give you a target and trying to search from this target if it's a target inside the 2D array or no. So um, so write an efficient algorithm that search for a value target in an m times n integer matrix, and this matrix have the following property. So the first one, integer in each row are sorted from left to right, and the first integer of each row is greater than the last integer of previous row. So that means the 10 greater than 7 and the 23 greater than 20. Okay, that's the property of the 2D matrix. So let's see here. So we give a target. Target is 3. If we have 3 in this 2D matrix, we return true. So here we give the target is 13. If 13 is not in this 2D matrix, then we return false. So this is basically this problem. Okay, so we can easily see if we so how do we solve this problem? We have different solutions. So we can actually iterate every single element in this 2D array, start from 1, 3, 5, 7. But this time complexity will be big O M times n. So because we are doing the iterate just one element, so let's do it better. So we can actually because we have because in each row we is sorted from left to right, so we can actually do binary search from left to right because it's sorted, right? We never will think about sorted. So we can do binary search from this row, do binary search for this row, do binary search for this row. So in this way, we did the time complexity for this row it will be log n, and we have m row, so the time complexity for this method is gonna be m log n. But can we use this kind of property for this problem? The property for this 2D matrix is gonna be the first integer of this row is greater than the last integer of the previous row. So basically, actually, we can just do a binary search, because we can start from here to here, and then from here to here, from here to here, right? So we can just read it that way. Now because we do have this property too. So because we have this property, we can actually just directly do the binary search. So if we do the binary search, this time complexity will gonna be big O log m times n. Yeah, because the total element in this 2D matrix is m times n. Okay, so let's start to do the code. Let's check the corner case. The corner case matrix equals to none, or if the matrix 0, the length equals to we check the row first, how many rows. We check a matrix the length equals to, if equal to 0, that means we don't have any row. And then we check the matrix 0 the length, this is how many columns do we have. If the column equals to 0, then what we do, we are going to return false. That means we don't have anything in this. We don't have our target in this 2D array. Okay, so and then we are going to iterate all the variable we're gonna use in this problem. So first, let's talk about the binary search. So when we do the binary search, first we need to we need we need a 3-pointer. Actually, we need a start. We also need an end. We also need a middle. Okay, and also we have a 3 main section of the binary search. The binary search we have this binary search. We have 3 main sections. So first we need to do pre-processing, and then we do binary search, and then we do post pre-processing. Okay, we will talk about this when we're coding. Okay, so first we have a 3-pointer. No, we have 3 pointer we need to use. So we have to define the start equals to 0, start equals to 0, the end equals to matrix dot length matrix 0 the length minus 1. Okay, and also we have a row equals to 0, and we have a column equals to 0. Okay, let's do the while loop. Let's actually talk about the search condition for the while loop. 1 second. For this binary researcher. So here we are using start plus 1 smaller than end. Actually, it's gonna be like which situation? It's like when we do the searching. Let's just give an example. I say maybe it's 4, maybe 6, 7, 8, 9. Okay. So when we do binary search of this example, so if the first one is a start, this one is a start, and then we have this one is end. Okay, this one is start, this one is end. Okay, so we are looking for the middle. So in this case, okay, because this one is a start. Okay, so the start plus 1. Okay, so the middle of this one is a start, this one is the end. Okay, so we are trying to figure out start plus 1 equal smaller than end. That means the ending condition for this one is gonna be this is start. So this one is a start, and this one is end, right? So and the start plus 1. If start plus 1 will be start plus 1 actually, and the end is gonna be the same one. See, it's gonna be the same element. So in this way, if start plus 1 equals to the end, the loop will stop. Okay, so have to be smaller than that. That means that when we run the loop, so when the start is here, the end is here, when they are neighbors, okay, in this way, the loop gonna stop. Okay, so that means we actually not checking the start and the end. So this both. So what we're gonna do, we have to do the post processing of this case because we need to check the start and the end. Okay, so let's continue. Where we are, yeah. So let's continue this one, start by end, and then we initial the middle. We have a start plus, we have end, we have by the start by 2. Okay, so we are doing this because we actually trying to avoiding the overflow. So that's why we do start plus and minus start by 2. It's not directly start plus end by 2 because we are trying to avoid the overflow. Okay, and then let's calculate the row. The row equals to middle matrix 0 dot the length, and then we are going to check. We are going to define the column. The column equals to middle, and then we're gonna do this matrix, and then we have 0, and then we have the length. Okay, so now we got the row and the column. So, and then we do check. So we check if the matrix is the matrix row and the matrix the column. So the matrix row and the column, actually we are checking the value of the middle. Okay, so if this value equals to our target, let's say, we just simply return true. Very simple one. We return true. Or if the matrix is row and the column, this actually we are getting the value of the middle. If this one, not equals to, we just actually, so if this one is smaller than the target, that means that we have to update. So smaller than the target, that means that our target is in the right portion of the binary search, the array. So we have to update our the start point. So here we're gonna do the start equals to middle, or we can do, or else what we do, we just do end equals to middle. Okay, this is a while loop, and then after while loop, because we just explained here, because our the while loop, inside the while loop, the search condition is the start plus 1 smaller than end. That means when the start and the end, when they are neighbors, then our loop is stopped, but we haven't checked the start and the end. So in this case, we need to come here to, we need to do the post processing to check the start. Here matrix, here is the 0, the length. Okay, okay. Okay, we will check the start, and also we check the end. Now we check the end. We check the end matrix and 0 the length, and then we check this row of the end. Now we are going to do the column of the row. This one. 1 second. Here we're gonna do here. Okay. Okay, if this one equals to the target we are looking for, let's make the code looks better. Let's just write it like this way. So if this one, then we just simply return true. Okay, but if we cannot find it, so if we cannot find this one, 1 second, let me check here, is that right? Yes. And then if we cannot find it, then we just simply return the false. Okay, let's run the code. Hopefully it's not gonna work. Hopefully. Run the code. No, it's not working. That's interesting. Let me check what the problem is. There's the end. This is the end of this one. Yeah, the problem is here. Okay, so the problem is here. It should be dot here. Okay, let's run the code. Okay, it's accept. Okay, it's accept here. So so it's accept. So let's submit. Okay, it's a success. So our code is faster than 100% of Java Online submission of the search to the metrics. That means we are our code is very efficiency. Okay, so let's talk about the time complexity for this problem. So the time complexity for this problem is big O log m times n, because m times n actually is the size of the array, right? The length of the array, and then the space complexity. The space complexity just on, because we didn't use any extra data structure. Okay, thank you for watching. I'll see you next time.